What if, tomorrow, the sky changed color? Not from pollution, not from a storm, but from something arriving. An asteroid, a chain of volcanic eruptions, a runaway climate shift. The cause almost doesn't matter. What matters is the aftermath. Because Earth has done this before. 5 times, in fact, over the last 540 million years, the planet has undergone what scientists call a mass extinction. A moment when the rules of survival are rewritten in an instant, geologically speaking. And here's the strange part. When the dust settles, it's rarely the biggest, the fastest, or the fiercest creatures that make it through. It's the ones nobody was watching. So if it happened today, right now, which species would actually walk away? To answer that, we have to go back to the last time this happened. 66 million years ago, an asteroid roughly the size of a mountain struck what is now the Yucatán Peninsula in Mexico. The impact itself was catastrophic, but it wasn't the fireball that ended the age of dinosaurs. It was what came after a global winter. Dust and sulfur aerosols choked the atmosphere, blocking sunlight for months, maybe years. Photosynthesis stalled. Food chains collapsed from the bottom up. And in that darkness, the animals that survived weren't the strongest. They were the small, the adaptable, and, strangely enough, the unfussy eaters. This is the first clue to understanding modern survival, and it comes down to something scientists call the detritus-based food web. Animals that could live off dead organic matter, seeds, insects, or decaying plants didn't need the sun to keep eating. Which brings us to an uncomfortable but telling fact. Some of the best-equipped survivors of the last great extinction were small, burrowing mammals, distant ancestors of today's rodents and shrews. Not glamorous, but alive. Fast forward to today, and the question becomes, who inherits that role now? Start with the obvious contenders. The organisms that have already survived not one, but all 5 mass extinctions. Tardigrades, for instance. These microscopic, 8-legged creatures, sometimes called water bears, can survive being frozen to nearly absolute zero, boiled past the point most life would combust, dried out for years, and even exposed to the vacuum of outer space. In 2007, scientists sent tardigrades into orbit and exposed them directly to open space. A portion of them survived. If almost nothing on Earth can kill them, what exactly would a mass extinction have to do? But tardigrades, for all their resilience, don't tell the whole story. Because survival isn't only about toughness. It's about flexibility. And that's where a very different kind of animal enters the picture. The crow. Crows, along with much of the wider corvid family, are among the most cognitively flexible animals on the planet. They've been observed using tools, recognizing individual human faces years later, and even appearing to plan for future needs. Behaviors once thought unique to primates. In a world thrown into chaos, intelligence like that isn't a luxury. It's a survival algorithm. An animal that can solve new problems on the fly doesn't need millions of years of evolution to adapt. It can adapt within a single lifetime. Then there's the cockroach, an animal whose name has become shorthand for indestructibility, and for good reason, though maybe not the reason people assume. Cockroaches aren't actually radiation-proof, despite the popular myth. But they are remarkably tolerant of it compared to many other animals, and more importantly, they're generalists in the truest sense. Able to eat almost anything, survive weeks without food, and reproduce quickly enough to rebound after a population crash. In the language of extinction survival, speed of reproduction matters almost as much as toughness. The faster a species can rebuild its numbers, the faster it can recover from a near wipeout. Which raises a bigger question. What about the ocean? Because if the disaster darkens the skies the way that asteroid once did, the oceans face their own kind of collapse. A starvation of sunlight that ripples all the way down the food chain. And yet, in the deepest parts of the sea, there are ecosystems that don't depend on sunlight at all. Around hydrothermal vents, cracks in the ocean floor that spew mineral-rich, superheated water. Entire communities of tube worms, vent crabs, and bacteria thrive on chemical energy instead. They've been doing it for hundreds of millions of years, entirely independent of whatever chaos is happening above the surface. In a very real sense, If the sun itself were blotted out, these vent ecosystems might not even notice. It's a humbling thought that some of the safest real estate during a global catastrophe isn't on land at all, but 2.5 miles beneath the ocean surface, in total darkness, next to scalding volcanic vents. But what about the animals we know best? What about us? Human survival in a mass extinction scenario is a more complicated question, because unlike other species, we're not just biological, we're technological. Our fate wouldn't hinge purely on physiology, but on infrastructure, cooperation, and knowledge. History offers a sobering hint here. The eruption of the Toba supervolcano roughly 74,000 years ago is thought by some researchers to have triggered a volcanic winter severe enough to strain early human populations, though the size of that impact is still debated among scientists. What isn't debated is this. Humans have already lived through climate extremes before, using exactly the traits that tend to define evolutionary survivors: adaptability, social cooperation, and the ability to store and share knowledge across generations. Which brings the story full circle, back to that pattern first written 66 million years ago. Survival, it turns out, has almost nothing to do with dominance. The Tyrannosaurus didn't survive. The largest, fastest, most fearsome animals almost never do. What survives is the creature that can eat what's left when the usual food disappears. What survives is the organism that can wait out darkness in a state of near-suspended animation. What survives is the mind flexible enough to solve a problem it has never faced before. So if the sky changed color tomorrow, the winners wouldn't be decided by strength. They'd be decided long before the disaster ever struck, by every small, quiet adaptation that seemed unremarkable at the time. The water bear that could shut down its own metabolism. The crow that could recognize a new kind of danger. The worm that never needed the sun in the first place. Maybe that's the real lesson buried inside every mass extinction the Earth has ever endured. It was never really about the disaster. It was about who was already prepared for a world they couldn't yet imagine.